Now let's see the question number 2. Question 2.1. A man wishes to load a refrigerator on a truck using a lamp at angle theta. He claims that less work would be required to load the truck if the length L of the lamp were increased. Is his claim valid? In fact, this is an example in the book. If you look at the book, you will see this example. And the problem is that if you want to load a refrigerator to the truck, like this, and the lamp has length L, and the theta is here. And in the problem, he claimed that if he has a longer L, he will do less work. The question is that is this true? So first we have to know what is the work he has to do to load the truck. You can see that in this case the work he has to do is the change in the potential energy, right? If we assume that the velocity of the refrigerator is a constant, if the velocity v is a constant, so there is no change in the kinetic energy. The work that the worker needs to do is to increase the potential energy, which is equal to mgh. You can see that the work is depend only on h apart from m and g. So it means that if you have the same h, the same height here, the same h, whatever the value of L or the value of theta are, you have to do the same work, right? Because here you can see that W is depend only on h. So it means that his claim is not valid because you cannot reduce the work by increase the length L. Now let's see the problem 2.2. A dart is inserted into a spring-loaded dart gun by pushing the spring in by distance x. For the next loading, the spring is compressed at distance 2x. How much farther does the second dart leave? You can solve this using the conservation of energy. We have that the elastic potential when you compress the dart is equal to the kinetic energy when the darts leave the gun. Okay, so the first round you have the elastic potential is equal to the 1 over 2 of kx squared is equal to the kinetic energy 1, which is 1 over 2 of mv1 square. And for the second round, you have this is the 1 over 2 of k 2x square, which means that it is 4 times of 1 over 2 of kx square, which means that it is 4 times of 1/2 1 over 2 of mv1 square, which means that it is 1 over 2 of m2v1 square, right? So it means that the velocity is 2 times faster, or 2 times as fast as in the first round. So we have to choose B. Okay.